So, morning everybody. I'm here to talk about mobile applications, Android mobile application security. So my end goal here is not the stage 2, but it's to give you an insight of the things that you shouldn't do and what best practices that you can do while developing Android mobile applications. So I'm a penetration tester at Integrity. On a daily basis, I'm working on web applications, infrastructure, and mobile applications. I hold a bunch of certifications, and while I'm not hacking, I will be doing usually landscape photography. So let's start. The area of the network is usually, from my experience, the part that has more problems, and we find more issues on applications on Android. So this all relies on HTTPS, and this involves certificate validation. So this is usually where applications tend to mess up. In this case, the validation implies several things, including the chain validations, guaranteeing that the host name presented by the leaf certificate is exactly the one that we were expecting, expiry dates, and other checks that are going to be done. And lastly, we have an optional step as well that is called certificate pinning that I'm going to talk about a little bit more later. So this is usually the normal object that we use to communicate with the server, URL connection. And okay, perfect. We have, in this case, I get a gig to develop an application for PixelScamp. So this certificate is completely legit, everything is okay, and everything is validated. But the problem is when we have this scenario that is the most typical, okay, we have a local development server with, let's say, a self-signed certificate. So when I'm developing the application, I get a bunch of errors and I can't connect to the server, so heck. So when I have a problem, what are we going to do? Let's Google it. So I reach Stack Overflow, some nice guys point me to a solution. Okay, you can get rid of those pesky errors by doing some different things to the normal object. So, and this is where things start to get wrong. We just had an objective that was get rid of those errors, but without knowing what would be the real impact of it. So the first scenario was that self-signed certificate. So the developer was Googling, okay, I found a solution to get rid of those errors. It implies to create a SSL context. We're going to initiate the context with something that is called the trust manager. And I'm going to create something that is, in this case, my custom trust manager that is going to be my super custom trust manager, okay? I'm going to make the request, just I will do normal certificates, and I'm going to initiate, I'm going to create a self-socket factory with that context. So, and what is going to be the structure of that custom manager? So, this is the issue. Here we have basically a structure without doing anything, but hey, the error went away. So, okay, mission accomplished, I can continue my development. So this is the first scenario, okay. The second scenario, we have a valid certificate, but actually is not the host name that I was expecting. So the certificate is valid, but it's not the right host name. So what I'm going to do, so let's Google it again. So I find another nice guy at Stack Overflow that pointed me to another solution. That is to implement a default hostname verifier. And you can see there, we are going to override the verify method, and it's going always to return true. So, okay, perfect. I have two scenarios. I no longer have HTTPS errors. Okay, all good. So I don't know if that is going to be all good. So what are we going to have next? So let's imagine that Ron is using your application on this Wi-Fi hotspot, and let's say that Elliot is also on the same network, seeing what's going around on the network. So what can be the issue here? Since your application on those both scenarios are not validating correctly the certificates, it's going to be able to do man-in-the-middle attacks. So man-in-the-middle attacks, for those who don't know it, is an attack that is going to be able to intercept all the communications, in this case for this mobile application. So another interesting impact is the manipulation of the return information from the server. And I'm going to give you a cool example of what could be the impacts of manipulation the return information on the server. So just so you guys have an idea what that implies, for the first scenario, where you basically invalidated all the validation of the certificates, an attacker could be presenting the application any kind of certificate. It could be a self-signed certificate. The application is going to accept it without validating anything. On the other scenario of toast name, the attacker needs to present a valid certificate, but there could be a completely different one. So your application is connecting to pixels.camp, and you could have a certificate presented to evil.camp, and the application would allow the communication to that application. So, as I said, there was an interesting vector of the returned manipulation of the return information. So, and web views are the perfect candidate to explain that. So here the developer is going to implement a web view and connect to the URL. So in this case, we also have the same problem. We have a self-signed certificate, and it needs to find a way to bypass it. So web views also have a method to bypass those SSL errors. That is called onReceived SSL error. And here I'm doing an endward.proceed. This basically ignores the validation. OK, you have an error. OK, no problem. Continue ahead. So OK, we have an issue with man in the middle. So what else can web views create here? There is something called JavaScript interface. For whatever reasons you would like to JavaScript to interact with Java, but sarcastic comments aside, this is useful because, let's say, OutSystems just gave a presentation of their mobile applications. They use Cordova, and that's the way that Cordova can interact with native code, is allowing to JavaScript to interact with Java. So that's the reason why exists the JavaScript interface. So here we have several issues. OK, so you have a web view that does not validate certificates. The web view has set JavaScript enabled, so you run JavaScript, and it has a JavaScript interface connected to it. So this has a funny impact what an attacker can do. I'm going to show you a quick demo. I have an Android application installed there that has all that configurations. And I'm going to show you first the application is going to connect to pixels.camp without any issue. And then I'm going to be man-in-the-middling the application and exploring a vulnerability that exists on JavaScript interface up until the web views of API 16. So the impact for this is I'm going to run the application. I'm going to view the site of the pixels.camp without any problems. And then I'm going to open the application again. But this time, I'm going to do a man-in-the-middle attack and exploit that vulnerability. What you're going to see on the left side of the screen is basically I achieving remote code execution on the device. So I have basically a command line for the device of that person connected to the malicious, in this case, in a public hotspot. So I can do any types of commands running on the context of that application. And let's say I have all access to the SD card of the mobile device, and I can extract all that information. Okay, so this is a really impact issue. So and Ron is not happy with that. So what else? Okay, we have just seen all the bad things that you shouldn't do. So that is the first thing. So how about good things that you can also do besides not screwing around with the basic configurations of the security mechanisms of the HTTPS? So there is something called certificate pinning. Without getting into much technicalities, we can assume certificate pinning is like a white list of certificates, is a list of certificates that the application is going to trust And if the server that the app is connecting to does not present those certificates on that list, the application is not going to connect to it. And this is a way to guarantee that the person talking to you is exactly the one that you were expecting, and not some other kind of potential attacker in the middle. So this is an example straight from the developer training kit of Google that gives you an example how to create and how to implement certificate pinning. So here we are going to create a certificate factory. We are loading a file that is a raw file. This is basically, I've exported the public certificate of pixels.camp and imported the CRT file directly to the Android application, and I'm referring this file here. So next, we are going to create a key store object that is going to store the certificate. Here, I'm creating an alias for it that is called pixels camp list certificate. Next, we are going to create a trust managed factory that's similar exactly with the previous example where we basically did nothing and was going to invalidate. In this case, this trust managed factory is going to trust only on that certificate that we imported. So, like the other example, we are going to use again an SSL context, and we are going to initiate it with our trust manager. And finally, we're going to do the connection that we do normally, and we're going to define the SSL socket factory for that URL connection with that socket factory. What this accomplishes is that the application is only going to talk with that specific certificate. So if the server is not presenting that particular service, the certificate, the application is not going to communicate with it. So recommendations. The first is easy. Don't mess with what is in place for security. So it's better to find the right way to correct stuff. So there is plenty of options. We already have free certificates with Let's Encrypt. You could also have a solution that you create. It could be your own certificate with self-signed certificate. You just need to import that certificate to your device, and so that particular device on your development is going to trust it, and you no longer have errors. And when you publish the code to production, everything is working as expected. Certificate pinning is a bit tricky, so it implies some requirements. So this should only be used for more critical information. Because, let me give you just a practical example. If the certificate expires and you need to renew again, you need to push another update for the application because the certificate is going to be different from the one the application was looking for. So this is a solution where you have to choose between security and the issue that you may have to do the updates on the application. So how about storage? Storage, and here I'm going to focus on a particular component that allows you to expose files and SQLite information, for example. And I'm going to talk about mainly now, it's about the file content provider, and I'm assuming that the component is exported for this example. So we start by creating a content provider. All this gibberish, basically what I'm going to define is a URI that is going to have a format like content / the my authority, that is pt-cláudio.security, and then we have what type of information that the content provider is going to be looking for. In this case, it's a folder and a file. Basically, what I'm creating here is an application for, let's say, a file browser on the device. So we have here a method that is called openFile, and here we have the open file that is going to be made on the application. So the first parameter, I'm defining what path the application is going to be looking for. In this case, it's a string that I've created that is basically /SD card. And here is going to process the URI that is going to be sent to the content provider, and is going to be using this get path. I'm going to show you what is going to be done on the background. So I have here another demo that I'm going to show you the application working normally, and I'm also going to show you an exploit that is going to, a third-party application that is going to exploit a vulnerability on this particular application. So, okay, this is the application, the file browser. As you can see, you have all the information in the SD card. Let me just go back a bit so that you can see. Okay. So I'm browsing the SD card, and I'm opening a file that is a certificate that is on the root of my SD card. And as soon as I open this, as you can see, the URI that I'm sending is the one here, okay? And this is what the function getPad is returning me, is just the file. So the application is going to be open the file. And then I'm going to manipulate a bit the way that this application is working. So I've come up with a different type of information. And what I'm doing here is something called a pattern reversal attack, that I'm going to exploit the normal behavior of the content provider. But in this case, I'm using pattern reversal. Let's see what is going to happen when I do this. So I'm going to run my application. And my application is going to show me that particular file. So I have a third-party application using the application that has the content provider, and I'm reading files based on that interaction. So, okay, so you can see here, we have a different type of behavior. So the getPad is returning all that pad, and that is what is triggering the vulnerability. So for the bonus points, you can also do this because the content provider is running on the context of that particular application. So that content provider is going to have access to its own private directory. So I'm indirectly breaking the sandbox of that application. So a third-party application is reading the local files of another application via that content manager. So how about recommendations? So ask yourself if you really need that component exported. That's the first thing that you should do. Another critical aspect is that content providers are exported by default on versions under 16. So if you did not explicitly define it as exported equals false, that content provider is exported on those versions. Even if you're targeting versions above this version, when you install that application on these particular versions, that content provider is going to be exported. So that's a crucial thing to know. So another thing that you could implement is permissions, so that even the component is exported, only an application that has the right permissions can export, can connect to that content provider. Also, a good practice is validate everything you can. So in this case, one thing that you could do, among others, is to validate what you are receiving. So the file getCanonicalPad helps a lot. So I'm going to show you a particular example. On my first request, the getPad only returned the name of the certificate, but if you use getCanonicalPad, you know the absolute pad that the application is going to be opening the file. So if you use that for my attack, you can see clearly that the request is not for the SD card, but in this case it's going to be for system. So you could create a whitelist of locations where the application is going to work. Everything besides that is going to fail. So how about SQLite content providers? So we start off by using a method called query. You have some parameters that you may be wondering what the meaning of they are. So the projection parameter is, let's imagine this on a SQL query. The projection parameter is regarding the fields that we put normally on the selected of the query. The selection part is where is on the part of the condition of the query. The sort order would be the information that we put on the order by. So we continue by creating an object that would allow us to define the table that we are going to query. create the object. And this part of the code is important because I'm going to be doing a query and I'm passing directly the received values of the projection and the selection, and this is important for what I'm going to show you. So this is an app that is basically a notes application that you can store notes, and you have a secure option when, by entering a password, you have a secure area where you could store credentials, whatever. So, okay, I'm going to open some notes. Okay, on the context menu of the Android, you have then a secure option. I'm going to put a password, and I'm going to see different notes that were on that view. So Pixel stored secure credentials there. So this seems to be different tables. So I'm going to create an application that is going to exploit that vulnerability. So this is the normal behavior. I'm querying the content provider, the SQLite content provider, and I'm seeing those two nodes that were on the non-secure area. So okay, so is there a way that I can try to get to the secure nodes? So, like you've seen, the selection and the projection parameters were being inserted directly in the query. So what I can do is, in this case, is try to do an SQL injection attack by defining the projection section of the query. So this basically is going to bypass all the stuff that was on the right of the query, and I'm going to query a table that exists in the SQLite databases that has all the structures inside the application. So this is going to allow me to at least determine if there are more tables hidden on the application that I cannot see from an external point of view. So as soon as I run this, I have the content of all the tables. And here allows me to see that actually there is another different table that is called node secure. So, okay, so I know the name of the table. So I can use exactly the same attack, but in this case, I'm going to use that particular table, and I'm going to be able to reach that information using the manipulation of the projection. So this is not good. So another interesting thing that can help you regarding SQLite injections, not particular for that case, but for cases where you receive input of the user that you somehow do not control, the selection arguments can allow you to do like parameterized queries so that you are not concatenating strings and create SQLite injections. So this is going to be used by orders. So you define on the selection the name of the fields and the placeholders, and they are going to be filled by the same order that you create on the selection argument. So when you pass this to the query, it's going to respect that. This way you are going to prevent SQL injections if you are receiving some kind of input from the user. So how about recommendations? The main ones are pretty much the same. When possible, try to exploit projection as selection. Don't let it export in a way that external users can define what kind of projection as selection you are using. So if you know what type of information that the view is going to be needed, you define it already, what type of information, what type of fields and conditions you are going to define it. And when applicable, you can use the selection arguments for preventing SQLite injections. So how about backups? This is an interesting thing. Only when actually it was my colleague Herman was talking about iOS and was wondering if Android also have a way to filter what is going to be backed up when you do an ADB backup or the auto backup that is going to the cloud. iOS has the way to filter that. Android didn't have that until version 6, and I learned that exactly when I was creating this presentation. So in Android 6 and above, you have something that is called full backup content. What this allows you is to indicate what type of files and contents you want to include or not on a backup. This is very useful because let's say that you do a full backup of the application. Lots of times you have sensitive information there, credentials, tokens that do not expire, something that for the user, when he's returning the application, may not be critical. You just need to put the information again, and he has guaranteed all the information that he may have on the application. So how we can define this is pretty simple. So you need to create xcodes file on the resources /xml. On the Android manifest, you defined this part of the full backup contents and reference that file. And the content of the file is pretty straightforward. In this case, I'm excluding the shared preference file of the application. So if you do an ADB backup or the auto backup to the cloud, the shared preference is not going to be included on the backup. So you have more options to use. There is a particularly interesting one that is includes. If you define one single include, that is the only file that is going to be included on the backup. So if you want to backup everything except one thing, it's better to think the way around and just exclude that particular file, because if you define a single include, everything else is going to be excluded from the backup. So that is an important aspect to take notice. So, all about the new stuff that came with Android 7 and Nugget. I think the most interesting thing is something that is called network security configuration. And this basically gathers much of the information that I talked previously in an easy way. So you don't have to write a bunch of code to guarantee those functionalities. So this feature, this network security configuration, allows you to customize trusted CAs, like say certificate pinning, for example, or guaranteeing that in a couple of weeks ago, there was, for example, the distrust of a Chinese root CA that was emitting rogue certificates. This allows you, okay, I don't want to trust certificate, I just want to trust on these particular ones and I don't care about the other ones. So this allows you to do that. This is very cool. So you have your local development server and you're using your own certificates. You don't have to mess around with a lot of things. You can import, okay, so for debugging, while the application is on debug mode, okay, you can trust the certificates, and the application is work perfectly without HTTPS errors. But as soon as the application goes into release mode, it's going to distrust that CA, and it's going to respect the normal CAs. This is very cool. iOS was, I think, is already using this. It's going to guarantee that all the applications talk with HTTPS without HTTP. Android finally think this about, and it created a method that you can define the domains and subdomains that application must guarantee that is going to only talk with HTTPS. It is not going to, even if you define somewhere code that is going to be used, HTTP is not going to do that request. Now comes a big fail from Google, because web views do not respect this condition. I don't know why. So web views are the only one. This is inclusive. It's not very, they don't put very attention to it, but if you read the documentation about this, you have a footnote that says, note, the web views do not respect this. So I don't know if they are going to fix it. I hope so. So, and the last thing, obviously, is the certificate pinning. And this is very cool because you just need to define a fingerprint of the certificate. You don't need to write a bunch of code. You just need one line that you say, okay, the certificate is this, trust it. It's basically this. I'm going to show you a quick example of the no clear text option. So you need to create a network security config file on the resources .xml. The name of the file needs to be exactly this. So on the manifest, you define that network security config and you do the reference to it. And this could be something simple as this. This site is pretty cool, thebearssl.com, if you don't know it. It has plenty of scenarios that you can use it to try to determine the behaviors of the application. It has a lot of scenarios, like expired certificates, long ghost names, weak ciphers. It has a lot of options that you can use. And this, I'm defining it. OK, so you cannot talk HTTP with this website, so with this domain and subdomain. So if you try to connect this, the connection is going to be aborted. So talking sheep, show me the code. I created all the application, all the projects and exploits for those projects that I created are available on GitHub, so you can download it and mess around with it and learn new things. Okay. So, and basically, is this what I was aiming to explain? So if you have some Q&A, go for it. Anyone? Offense in general? No? OK, I think it's done. OK, thank you for your time.